14 pounds, 5 ounces, 6 ounces. But I wasn't getting the full current. This should be pulling with this with this setup, should be pulling close to 50 amps. Up to 600 volts.
Motor repair, take one.
There's 4 bolts here. That shaft moves this lever. It's alive! This is the third episode in the Electric Challenger Ultralight project. I still need to figure out a good name for it. Again, open to suggestions. This episode is going to be less me hitting things with a hammer and more talking, so if you find it boring, my apologies. But I'm going to be talking about motor selection, propeller selection, and ESCs, and walk you through how I'm going to be doing that testing. I've done some of the testing, got some initial data, but just kind of giving an overview of what my approach is and what I'm trying to accomplish. So, you know, how I want to test these to make sure that they're going to be safe, reliable, give me the right amount of thrust and power output. And so, yeah, that's what we'll cover today. All right, this is the, I'll say fun part. I don't know, I think it's fun, but I'm weird. Lots and lots of testing. I need to figure out what motor and what ESC I want to power the Challenger. So I haven't decided right now. I've got a bunch of testing that I'm doing. I'm playing around with the VESC. That's the one that was done by Jason Vetter. It's an open source design. And it's become quite popular with the eSkate guys. And being open source, it's made by different companies. I got one from Flipsky, I've got one from Maytech. There are other sources as well. And the problem I'm running into that is that with this design, you see the heat sinks, or the MOSFETs are soldered opposite sides, so that it's actually hard to cool this. It's supposed to be rated for 50 amps continuous, but my testing, I've been finding it's more like 20, 25 amps continuous. Not super surprised. This is a thing that I've been running into in these ESCs that I've been testing, is that, let's say, a lot of the manufacturers are optimistic as far as their current ratings. I think it's the throttle sensor that I'm planning on using. This is actually from a Dodge truck. Can't remember what year. I selected it because it's actually a redundant. If you look in there, there's actually 6 connections because there are 2 Hall effect sensors in here and give a 0 to 5 volt signal out. So I will run one throttle. Actually, I might run 2 of these, and then the signal splits off and then controls half or a quarter. And this, we're running 2 of these, a quarter of the ESC. So if I do have a throttle drop out, the worst case is I lose just that power, not all of the power. Likewise, if I have a runaway situation, I can just turn off that bank and not the others. So that's what I'm going to use for the generate a 0 to 5 volt. The thing I'm debating is there's several different ways that I can build design safety into the system. One is I can make things redundant. That does add complexity and also potentially adds failure modes that you might not consider. You got to assume that at least a single point failure, that you can account for that. 2 points of failure would be even better. But so if an ESC, for instance, if an ESC fails, sometimes these will fail open short circuit, and then you got to make sure that you have a system to protect that. So that would be a fuse that would also blow, or a contactor that you would close. And then it's still nice to be able to fly. So that's having the system set up so it's redundant. Or in this case, well, I said I'll have probably 4 different motor channels or banks that I can, if something goes wrong, I can just turn off 1/4 of it, and that would be evenly distributed such that I won't have a asymmetric lift problem. So anyway, a lot of options, a lot of choices. Haven't quite decided what I want to do. If I just want to build it and fly it, I'll just use a simple 2-wire control. It's a lot of options. So the next couple weeks, really probably over the next month, I'm going to be doing a lot of different testing with different motors, ESCs, and seeing what happens. All right. Well, I'm just doing a initial test here. It's the first time using the ESC. This is actually one from Flipsky. It was like between $60 or $80, somewhere around that range, which is probably one of the most cost-effective options. But cost-effective also usually means cheap. So we'll see how that goes. Got the thrust set up here. Yeah, doing everything in pounds and ounces. Apologize to everyone else out there. But like I said, this isn't a real motor test. I'll do a much better job for instrumenting that. But right now, I just want to try out this VESC and see how it works. Pulling 9 ounces, not a big deal. It's a whopping 1 3/4 amps. So let's crank it up. $13.5 amps. Turn my current meter here, close the contactor. Got it set up on a big Gigavac overkill contactor, so I have it all safe when I go to work on it. Saves me having to unplug and plug things in over and over. All right, so this Rimfire 1.6 is not the motor I was looking at using, but again, I already had it on the test bench, and this 3-bladed prop should be matched for it, or at least matched better. But let's try it out and find out. Buttons, I like this, the accuracy of this, but the buttons on these you really have to mash. All right, already teared. Like I said, this is the Rimfire 1.6, and this is a much better, this 3-bladed prop's a much better match for it. The 24-inch was actually set up for this big guy. This is a Rimfire 50cc. It is, yeah, it's definitely overkill for what I'm looking at. Can't remember if I've done static thrust test on this with the big prop or not. We should do it just for fun. This is, you can see my beautiful motor mount there. Allows me I can swap motors back and forth quite easily. But anyway, this is a 12mm bolt hole. So the problem is any prop that I would test out on this, then I would never be able to. I can drill a hole bigger. My hole shrinker is in the shop, unfortunately. But anyway, I've got more motors on the way. I just want to try out different ones. This is the Maytech motor. I've got some custom winds from Maytech that are on order. They've got a really nice price point. I mean, this class of construction is, from what I've seen, all about the same. Now, T motor, which is actually Tiger Motors. T motor, I think, sounded cooler. I agree with them. Their construction is definitely optimized for low weight. So these guys, these Maytech ones, power to weight ratio isn't as good, especially continuous. They're made more for, these are really popular for the skateboard guys. I keep wanting to build one of those, but I can only build so many things at once. But yeah, these are really popular with the e-skate guys. The ag drones, the weight difference, just put like this motor and propeller is significantly lighter than just this motor. Like I can tell that with my calibrated hand. Yet they will have about the same torque output. And all comes down to the way this is wound. This is a 170 kV motor. This is, if I remember right, is a 270. I think the ones I have on order are 190 or 180 kV. There's a really key point of this is getting your propeller matched to your motor. And the other thing with the propeller is it's not just the propeller diameter, but it's also the pitch. So this is a 6.6, which will produce very good static thrust, but there'll be essentially there's a speed limit at which the advance ratio of the prop isn't sufficient to go any faster. Which again, for this class of airplane, is I'm going to be operating in the around 30 mile an hour to 40 mile an hour range realistically, and which is where I want to be. But that advance ratio this is a 24.8. That pitch, this will give me a lot more top speed, even if they were the same diameter, which is not. These are 22s, and this is a 24. So, a lot of different variables that you can optimize for. If you get any one of them wrong, you could have the perfect motor, the perfect ESC, the perfect battery, and then you throw the wrong prop on it, and you're like, I'm not making enough power. It must be the problem of this must be these motors are bad. Well, no, you didn't put the right propeller on. So.
I want to go through a little detail on 3 of the open source ESCs that I'm looking at driving the motors with. First one I'll start with here. This is a Flipsky ESC based off of Vedder's design. This is a 4.12. 4.12. Actually, Flipsky makes 2 of the VSCs. They make a 4.12 or 4.11, I can't remember which, and then a 4.20, which they call their mini VSC. I can't remember if that's actually a real version. I think they're the only one I've seen that makes that. But anyway, original version 4 VSC design. You got the capacitors up here. These are 12 gauge wires coming into your power. This is for the MOSFETs. The capacitors are wired together, obviously in parallel off of that, so it'll smooth out your input voltage. And yeah, past that, it's fairly straightforward for the design. You've got your inputs for both. There's CAN, there's 0 to 5 volts, there's USB, so it's still micro USB because it's the version 4, and then 12 gauge leads on there. So starting with the power side, you get relatively short leads. Then you have the capacitors. Fortunately, these are no-name Rich Cap. I'm not familiar with them. Did a little Googling and didn't find much of anything. So very questionable how long those, what the quality of those capacitors are. Past that, you've got the 4.11 MOSFET, which is that one, so I'll repeat out the number. But interesting, just looking over it, the soldering quality leaves something to be desired. You can see the position of this MOSFET isn't quite centered. The solder is, I don't know, let's just say, not up to my standards, not like I have super high standards for my soldering, but likewise again here, it's a cold solder joint, but past that, not too much really to add on to it. Let's just say it's not the The MOSFETs are the standard ones, but capacitors and just the overall quality of the board, it's not terrible, but there's some questionable spots looking through here. Oh, and I have tested. Oh, one of the things with the version 4 is you can see that the MOSFETs sandwich the PCB, and the problem with this then is it's hard to get the heat out. That's I think a big negative I have with version 4 the ESC. Past everything else, I like it because it's so configurable. There's so many inputs and outputs. It's, you can log on to the computer and get your throttle and RPM, set current levels. It's a lot of functionality, and it's still pretty plug and play. But what I found, at least the very initial testing I've done of this is supposed to be rated for 50 amps continuous. I've taken off the plastic that normally comes on here with just open air, and when I test it with open air, I'm getting more like 20 amps continuous. I think part of that's because what some people consider continuous doesn't really get tested that way, because there's just no way of, their application. If you're on a e-skateboard or something like that, you're not really going to be able to throw that much current for that long. But with a test bench where I can just run it for minutes on length, you very quickly find where that thermal limit is. And but it does do a good job of, I think the high current is set to keep below 85 with a hard shut off at 100 Celsius. And it does throttle back to protect the MOSFETs from damage. And it tested that a few times, and at least that portion of it does work. It doesn't. I'd rather it do that where it gives me less power than it just keeps giving me power up to the point where it stops working. But I really want, obviously, a system that's going to give me the full current that I need. So, next one here. This is another ESC design just from Maytech. Nice thing, starting at the top. This is a Rubicon capacitors. It's a well-known brand name Japanese company that's been around for, I don't know, very long time, probably longer than me. Yeah, I mean, putting these guys side by side here, almost identical. There's some differences on the board level design to where some of the positioning is done, but I think they did a better job on the soldering as far as the current flow, current path. They actually they don't just go to the pad, they actually come up and then tie in here, which is going to give you more area for current. You don't have to worry about, less concern about desoldering. So you've got the same MOSFETs here, same TI chip. I have to pull off that to actually see what the brand is under that, but that's that very similar. The Maytech board, which is this one, looks more populated just because they actually go through and they label all of their stuff, which is a nice little bonus. But generally, I definitely think that the soldering and quality looks, just from visual inspection, does seem significantly better on the Maytech as opposed to this one, Flipsky. A couple things with that: I just bought these. It could have been that this was a bad day. It could have been that this was a particularly good day. It's very hard to tell with a sample set from one. I'm going to do every single one of these. If I use these, or any of the ones I use, I'm going to bench test for at least 10 or 20 minutes to make sure that it meets all of my requirements. Same limitations as far as cooling. Architecture is exactly the same. Just a little bit higher quality on this. I'm curious to see whether or not this will actually output anywhere close to the 50 amps continuous that it's rated for. I don't see why thermally this is going to be any different from this guy here, where I'm only getting about 20 amps continuous on this one. But same thing, other things apply, very configurable, lots of methods of communication. The nice thing about with the version 4s is that the price is very reasonable. I think you can get these on eBay, the Flipskys, for about $60. The Maytech, getting them direct, it's a little bit more expensive, but that's very worth it to me for quality. Time will tell. I actually have to get this on tested and working from there. So that's the ESCs. There's a version 6 was newer one out. The problem with that is it's significantly more expensive. I think the version 6 ESCs are running in the $120 range. Obviously, I want to make sure that I'm not just going for the cheapest one possible, because that's I need something that's going to be reliable and meet all of my needs. The other open source option here is this is the ODrive. O stands for Oscar, is the guy who designed it. Open source design. It's like the Benjamin Vetter with the VESC. All the plans are available on this. I think he's on GitHub and Hackaday. General, this is actually made for automation equipment, for actually a CNC. So I'm not really using it for the intended application. But that being said, I mean, just looking over the board, it's I really like the design, very high quality on the manufacturer as well. I've been impressed looking over this, the components selection and just the overall manufacturer. Big change is that you can see these sets of 4 MOSFETs here. Nope, not that one. Are for the are the power MOSFETs, and for the 3 phases, and they're all spread out, so you don't have that's from the backside, but you're not trying to dump heat into each other like you are on the VESC. So cooling wise, and what actually turned me on to this is Oscar did some testing and actual continuous testing and found that he got it was about 30 some odd amps continuous with just no airflow, and with a small reasonable fan put onto it, he was getting 70 amps continuous. And he put all of his data and actually threw the chart up there, which I really like to see. Being an engineer, I like data. I've come to not trust manufacturer sales sheets, but very similar in functionality wise to the VSC. The big thing here is this is a dual ESC, because it's made for doing a 2-axis CNC machine, so you can control both axes. Price wise is nice too. This is I think about $150. It's a little more with the screw terminals. I wouldn't actually use the screw terminals in real life, but for testing they're great because you can swap things in and out very quickly. But you have 0 to 5 volt. There's CAN control. I think there's UART, PPM, and I think there's been a couple other controls that you can send. But and it's got a micro USB. I can't really see there. The disadvantage for this is that it's not nearly as plug and play. The ESC has been out there for a while, and a big user base. The software is really well matured. The ODrive, I'm not using it for its intended application. For doing a CNC machine, it's really what you need, but it's going to take a little bit more work for me to make it a standalone for what I want. But it's definitely an option out there. Even if I don't end up using this on the airplane, I've got my plasma cam CNC, and I've been thinking about ditching the literally almost 20-year-old control system that's on it, and this is actually going to be a real potential option. And then the last option is just going with a super simple one. This is FlyColor ESC I've used on another project. Rated at 80 amps. It's already water resistant. 12 gauge leads, and it's just a simple. I'm not going to get any kind of data out of this. I'm not going to be able to monitor the MOSFET temperature. I'm not going to be able to record RPM and current and voltage and all that fun stuff, which is the real reason why I'm liking this VESC. If I one other thing on the Oscar one is this won't really handle the full voltage of 12S. I talked to him about it. He is working on a 50 volt. Curious what changes it'll actually make to be able to do that bump in voltage. But I'd have to keep safe. I'd have to not fully charge up the battery. Anyway, all of these are 12S rated. But you know, 80 amp is what it's claimed. Again, I never trust the marketing sticker on the box. Capacitors are significantly smaller than that of the ESC. I think these are 650. These are 680 microfarad, rated for 63 volts, so it's got a decent head margin on there. 680 at 63, so there's a temperature rating on it. I'm sure I could look up that number and find out what capacitor is, but I mean, I'm probably not going to use this exact one. I just had this left over from another project, but I'll give it a shot and use it for testing. Again, it says 80 amps, but I'd be surprised if it actually does half that on a continuous basis. But anyway, those are the options. Let me know in the comments and see, are there other options I should be considering? If people have experience with any of these, good or bad, and let me know down in the comments. So I'm torn between I want lots of data and lots of functionality, and then I also want just to keep it simple. I don't know. That's what I'm going to do a bunch of testing over the next few weeks and see which ones of these survive the gauntlet and go from there. Oh, and one thing on this is I don't have the heat sinks installed. There are heat sinks that get installed in this. I just have them off so you can actually see the MOSFET arrangement. Anyway, let me know what you guys think down in the comments, and we'll get to testing.
By the way, honestly, I'm not sponsored by DeWalt. I think I've got too many tools. That one I've had for about 20 years. Oh, okay, 15. That one, and actually that one all came from a surplus auction. Sometimes you get good deals those. Alright, what do I have here? This is a box of props. Not props for the high school theater show. No. These are a collection of RC props. So the T-motor that you've already seen. But you see it's a whole bunch of those Turnigy motors. Turnigy propellers. I got these off of eBay. Kind of a funny story. I was looking around for how aggressive of a pitch could I get in this prop size, 22 inches. And so I just poke around, and I happened to come across these Turnigys, but they were discontinued. But I found them on eBay, and because they were discontinued, some store was closing them out. And so these are normally like a $20 or $30 prop. These are cherry wood, 22 inch in diameter, and 14-inch pitch. And because they were closing them out, they were $4 each delivered, as opposed to 20 or 30. So I got all they had, which is 24. Why was I wanting to get this? Well, I only needed 14. This is actually not going to be going on the Ultralight. This pitch is too aggressive. I would need probably about 4 or 5 horsepower to power one of these. But when I do the hybrid, I'm going to want a higher speed. That because I'll probably max out at around 30 or 40 miles an hour with the Ultralight. But with this pitch prop, I can probably top out around 80 miles an hour under power. And so that's what they got for there. So, because I only needed 14, but spares, and they were $3 each. So I kind of went off the deep end. But so there it is. I'm going to be doing a lot of testing of propellers, motors, and ESCs over the next month. I'm not going to put all of that on there. It would just bore everyone to tears. But I'm going to do probably episode 5 will be my conclusions on what I pick for motor, ESC, and propellers. Like I said, definitely looking for suggestions on ESCs. I'm still on the fence there as far as whether or not I want to go with a more plug-and-play option or something with more full features, especially looking for something that's reliable but cost-effective. Usually those two things don't go hand in hand, but that's what I'm going to be doing testing on. And yeah, next episode is going to be on more of me hitting things with a hammer. That's going to be the getting the Challenger frame all fixed up. It's just about done, back on gear, and be showing that here in just a few days. Stay tuned.